Let's see what we can do with this subtraction. Unfortunately, the denominators aren't the same. Would have been nice, but we don't always get what we want, right? In fact, the famous 20th century philosopher Mick Jagger, isn't that what he said? You can't always get what you want. Right up there with his philosophy of I can't get no satisfaction. He really was quite the 20th century philosopher. In fact, he's still philosophizing today, even though he's older than I am. But we can handle this. We can make those denominators the same. We have to first find our least common denominator, our least common multiple, and I really can't perform an analysis to figure that out until I start by factoring the denominators I have. X times x would give me x squared. One of them needs to be plus, one of them needs to be minus to get the minus 12. And I think if I go x plus 4 and x minus 3, that'll give me plus 1x under the O and the I of FOIL. Over here, they're both pluses in the trinomials. That comes from both addition in the binomials. X times x will give me the x squared. And if I take a 3 times a 4, that'll give me the 12, and it'll give me plus 7x for my O and I term. So there's my factored denominators. And now I need to use that to figure out what I'm going to use for my common denominator. Well, the common denominator will need to have these two factors in it. So that this factor could divide into it. Remember, isn't that the way a common denominator always works? Each denominator can divide into the common denominator. So the only way these two factors would divide into the common denominator is if they are present. Well, they'd have to be over here in this fraction as well then. But if we only have these two binomials, this denominator won't divide in there, because there's no x plus 3 factor for it to divide into. So I've got to include x plus 3 as part of the common denominator. Remember, a common denominator is a common multiple. So the factors we have here have to be visible in the common denominator. Just like if you have 18 and you had 27 as denominators of your fractions. Let's say you have 11/18 and you're subtracting from that 4/27. The common denominator there is 54, because 18 will divide into 54 and give us a whole number answer, and 27 will divide into 54 and give us a whole number answer. That's what your common denominator has to be able to do. It has to be the multiple of both of the denominators you have. And this denominator is a multiple of both of the denominators we have in our original fractions. So now I have to build those denominators up. This denominator is missing the factor of x plus 3. So I would have to multiply it by x plus 3, which means I'd have to multiply the numerator by x plus 3. Just like over here, 3 times 18 makes 54, so I'd have to multiply 3 times the numerator of that fraction. 2 times 27 makes 54, so I'd have to multiply that fraction by 2 over 2. Here, the factor that's missing, I've got the x plus 3, I've got the x plus 4, the factor that's missing is x minus 3. So I'd have to multiply both numerator and denominator of that fraction by x minus 3. We always have to build up our fractions to make their denominator what we want as the common denominator. Well, now, this is a binomial times a binomial. That's going to require FOIL. X plus 3 times x plus 1. X times x is x squared, plus 1x plus 3x more. That's plus 4x for the O and the I of FOIL, plus 3 for the L of FOIL. X times x is x squared. Minus 3x minus 3x more. That's minus 6x for the O and the I of FOIL. Minus 3 times minus 3 is plus 9. And we've taken the product of those binomials that were in the numerators using our FOIL method. Now we're ready to subtract. And when we subtract, we're going to put the answer over our least common denominator. That's what we always do when we add and subtract. We add or subtract the numerators and then put that answer over our common denominator. X squared minus x squared. What do those terms do? Don't they disappear into 0? X squared minus x squared would be 0. So there's no x squared term. Plus 4x minus a minus 6x. Remember what the minus sign is going to do. It's going to change the signs. So plus 4x minus a minus 6, that's going to be plus 4x plus 6x. That'll be 10x. And plus 3 minus a plus 9. So that's plus 3 minus 9, which is minus 6. And now we would see if we can simplify. Well, I can notice that what? There's a common factor of 2 in those terms. But if I factor out that common factor of 2, I'm going to have 2 times 5x minus 3, correct? 2 times 5x would be 10x. 2 times minus 3 is minus 6. Is 5x minus 3 one of the binomials that I could cancel there? It's not, is it? So it really doesn't do me any good to show the factored form of that numerator. I can't do any canceling. So it's perfectly fine to leave my answer just like this. Now, that's not a real satisfying answer. We like to see things cancel out so that it's less complicated. But sometimes in life, we don't get the less complicated. Sometimes in life, we get the more complicated, and we just have to live with it.